Hello, right, another Maker Advent, and we have success. Yes, yesterday was a successful day. This all took a little bit of time to put together, so if you haven't been following, there's some videos to catch up on. I'll put them in a link down below. This is a 555 snow globe. This is from the dollar store, from Poundland, whatever you like to call it, and it is just something to put snow in and a toy and glue it down and make it look pretty for Christmas. I saw it and thought, that could be a project box. And I thought, what else does Poundland sell? Well, they sell £1 LEDs for Christmas. Well, they used to. They don't sell very many anymore. So I got a couple of packs, and they're inside here. One is like a warm white with stars. The other one is just brightly coloured fairy lights. Both are lovely. I prefer multicolour, but hey. Now I wanted a way to control the LEDs. They were just static, boring lights. So I thought, okay, I could use an AT Mega, so an AT Tiny 85. I could use Raspberry Pi Pico, I could use Raspberry Pi if I wanted to, but I thought, hang on. There's a chip out there that does it all, and it doesn't need all that complex, programming. You just give it voltages, and it works out the maths, and it does it. That's for 555. So 555 is a timer IC, basically. And I'm using it in astable mode at the moment. So it has a capacitor which charges. And that charge denotes how long an output is on for. So it's sending power, and also it denotes how long it's off for. When the capacitor is charged, that charge turns on an output pin. The output pin then has 5 volts in this case, and the LED is connected, well, one set is connected to that via its positive lead, and the ground is connected to common ground. Capacitor charges up, it lights up the LEDs, and it's on for however long this is, about half a second roughly. When the capacitor discharges, so it goes down to near enough zero, the chip, the 555 here, is a flip-flop, so it flips over the output to become 0 volts. Pulls it to ground basically. That then gives my other string of LEDs a common ground, and they're wired up in reverse, so when they see ground, they're already connected to 5 volts power directly to USB. That flips over, changes the polarity, and it lights up the other set. And then when the capacitor charges, it flips back over, and the whites come on. Easy as that. He says, after 3 videos doing this. So my problem was, I wasn't paying attention to the resistors. I was just going, resistors, throw resistors at it. I was trying 10k, 1k, 100k, no. On here I've got 4.7k for both resistors. One for charging, one for discharge, like a comparison almost. A 100 UF capacitor, that's on pin 2 and on ground. That's it, that's a simple circuit. So I breadboarded all this. Luckily for me, in the previous Maker Advent, and this is like series 1 of Maker Advent, I bought a ton of 555s, all badly packaged. I watched a video last night, breadboarded it, understood where I got it wrong, thanks to an Element 14 video, which was fantastic. I'll put a link down below, and we have this. So what's going to happen now is, I'm not going to do this all on camera, otherwise it's going to become a very long video again, and it's going to be boring for you. LEDs are in place, that's how I want them. The base right now is an orange, yellow, yes, orange. The base is an orange puck right now. I don't want that, I want a different colour. So I'm going to 3D print a new base using this design, but hollow it out to fit in this circuit. This circuit I'm going to cut out, hot glue in the base of it, run the cable out the side, it's all nice and neat, and it'll go up on a shelf. There we are, that's that. But I said yesterday was a good day for making, it was. But on for scale, just go over here for one moment please. And we'll keep the LEDs in shot because they are pretty, and 3 videos of content there to make them, because I'm an idiot. Remember the other project, the charging base for the electronic screwdriver? Well, I 3D printed the final base for it. So you may have seen in a previous video a couple of attempts where I had this one as the first. That was the first, and I got tolerances wrong. They're about 1 mil out on this one, so bye bye. Second test, slightly thinner as well, so it prints quicker. Perfect. Also got rid of the posts, so I don't need them. Perfect. Like 0.5 mil, a little bit of wiggle when you put it in. No problem at all. Brill. That's a good test, so that spurred me on to do something else. Bingo. That's held in right now using blue tack. I still don't know what that's called in the States. Love to find out. Fits perfectly. So I printed this upside down. I'm not going to turn it upside down because I've got all my bits in here. In fact, yeah, I can do this, can't I? Printed upside down, it is Gridfinity. All that was supported, but everything else didn't need supports. So when it came to taking it off the bed, pulled it off the print bed, pulled all supports out of here, cleaned it up a little bit. Great. In fact, the roughness in there is going to work out well for me because I need to glue it in place. Some hot glue, and the roughness will sort of grab. So now, and the bits, easy peasy, they're 5 mil. They're actually 4.2 mil at the widest point, 4 mil bits between the flat sides of the hexagon. put 4.2 on the sharp points. They fit perfectly, and that's all 28 that come with this. And this will drop in place. And there we go. We have a charger. Again, it's still work in progress for that. Need to glue it in place, but it'll live on the edge of my desk like this, so the lead's going to go off the side for USB-C charging, and when I need a screwdriver, grab and go. So yeah, good day for making. Anyway, that's all for today. See you later.